So function definitions look like this. They come with the function name. The function name is followed by an opening parentheses, and when the compiler sees this function definition, from these parentheses, compiler decides the square identifier is the name of the function. Of course, the parameters are specified inside these parentheses. These parentheses can be empty, like main here doesn't want to indicate any input parameters and can be invoked without input parameters. But here we're expecting an integer parameter. So of course, if we want to call function square, we need to call square with some kind of value that can be converted to an integer. Okay, so the return statement returns an expression which in this case computes the square, and the function definition is using an integer in front of its name specifying the type of the value returned from this function. Of course, if we take an integer and we multiply an integer by itself, then obviously the result of it is also an integer, so we're returning it back from this function. Another example of function definition is display. So display is the name of the function, and it also takes an integer parameter. However, it just says that it's not going to return any values, and the void function return type is specifically designed to indicate that the function is not returning anything back to its caller. So here we're just printing the value of x, which is an input parameter, and notice the difference in terms of the making calls into square and display. And when we call square, we pass the value and we also accept the result. So this is an example of a function call that takes parameters and returns something back. So we just accept the value into the result, and then we take this result and pass it on to display, and so the display will get a copy of this result and will print the result using character output that of course is included right here. So the function definition format is function name, return type, argument declarations, so we call them parameters or function arguments. And this is called function body, right? So the body of the function is using the opening brace and the closing brace like this, and internally we have variable declarations and statements to implement the logic of this function. An absolutely minimal definition of a function would be a dummy function like this with no parameters, function that does absolutely nothing, so its body is empty, and it's also not returning anything back. Well, sometimes using these kind of minimalistic functions is okay, because you may decide to have this function and you can develop it later on, but at the beginning you just don't want to forget about it, and just you can type it somewhere in your source files and keep it at this primitive level until you have a chance to come back to it and start programming the actual logic of this function. All right, so we also have discovered this problem with function definitions and declarations. Let's bring everything to one single tab, and here, recall we had an issue with two functions calling each other. So this was already discussed in our example, and the downloadable code is available on our website. So you can download the entire project with all of these three files, and you can play with this code on your own. But this was our discussion, and this brought up the need for potentially a header file which separates function declarations in a common area, and now we can start including this header file in other source files such as ping pong and main right here, so that we avoid this uncertainty about function definition order. So if we made these declarations, and if declarations of functions match the function definition signatures right here, of course we avoid problem of undefined identifiers when we're trying to call functions which were not yet defined in a certain source file. One word of caution here is that if I want to add another parameter right here, just remember that you must add this parameter in both declaration and definition. So this has to match exactly, otherwise you will start getting error messages from your linker. Okay, so just remember, it's very natural that function parameter lists change, sometimes return type may change and things of that nature. But just remember that these changes have to be very consistent between the definition of the function and the declaration or prototype of a function. So of course I will undo this temporary change like this and just keep it in this state. And so this was already discussed in our demonstration today, as we came up with the final solution using multiple files, multiple source files, the header guard, the header file with the header guard, and everything that we were able to do. So this is a discussion of this of the set of ideas related to ping pong implementation. So you can also try to copy and paste examples from previous slides, and they should compile, and you can see how that program behaves. So there's a discussion of various versions of it, but I really like the one that we developed today. So this was, I think this is really does really good performance in terms of expectations of the user input and what gets printed, and I think it's also has a reasonably good design. So communication between functions is done through input parameters and the return result. So for instance, the maximum value is a function that basically compares two integers and returns x if it's greater, otherwise it returns y. So this finds the maximum value. Of course, there is a library function that's called max in the standard library namespace, but for the demonstration purposes we have placed this to demonstrate the input parameters and the result. And of course, return statement, what return statement does, it allows function to return a certain compute certain expression or take a variable value and return it with the specified accordingly to this type of the value that the function returns. Okay, so this is the idea of return mechanism using the return statement. Now, returning from a void function, which by the way we had in our examples, are both ping pong functions are void functions which do not return any values. They simply use a return statement without any expression attached to it. So this just takes you out of this function, plain and simple. So if this condition is true, then we can return. So the highlights of procedural programming approach, which is, remember, based on the combination of functions and variables. So that's our building blocks using structured programming platform design. And procedural programming is very efficient. It's very relatively very easy to follow in terms of its logic and its design. If it's well written, it can be very, very successful application. So the functions, as you can see in our example right here, the functions break large tasks into smaller ones. So that's very important to keep your functions small, well defined, with pretty clear set of input parameters. Decide what should be the output result type, and generally speaking, ideally functions just take just a few lines of code, as we have in our example right here. So functions enable people to build or what others on what others have done, because we can have these libraries of of functions already defined somewhere in these header files, that we can bring these header files into our program and start using functions defined by somebody else. And functions definitely hide details of operation from other parts of the program. So the meaning of this is that if we spend a long time developing a set of function definitions, we tested individual functions, we spend a lot of time, and we have pretty good confidence about our implementation of these functions. And now we can sort of like forget about all this hard work and just focus on their use, which translates into just single lines of code like this, where we start making function calls, right? So we just need to watch out for correct parameter types, and correct number of parameters that we pass to these functions, and we already know exactly what this function does. At the minimum, we can just open the header file and occasionally look up the correct prototypes of these functions, because for us, we can also supply a lot of comments over here, explain what this function really does. So we can refer just to the header file, see what the declaration looks like, and start programming it by simply focusing on function calls and expecting returns from these functions. So at this stage, if we already know, we already described in our comments or some other documentation exactly what these two functions do, we really don't need to see any of this, right? We just like, who cares? There could be many ways to write this implementation of this function. We just really need to know what is the input and how to make a call into it and what to expect back from a function. So this is the idea behind this. The actual details of the application can be hidden inside of modular design using structured programming, and it's a great thing, because then we can just call these functions and expect correct results from them.